Finding the power of a product. The power of a product rule of exponents. For any non-zero real number a and natural number n, the negative rule of exponents states the following. We have a base of a product of a times b to the power of n, which means we would have the base of a to the power of n times the base of b to the power of n. So for example number 7, we're going to use the power of a product rule. We're going to simplify each of the following products as much as possible using the power of a product rule. And we're going to write answers with positive exponents. So the first example, we have the base of a times b to the second power to the power of 3. So I want you to notice here that the a has an exponent of 1. So what we're going to do is we're going to distribute this power of 3 to both of the exponents. So we end up with a to the first power times raised to the power of 3 times b to the second power raised to the power of 3. And then what we're going to do is we're going to take a to the power of 1 times 3 times b to the power of 2 times 3. So 1 times 3 gives us a base of a to the exponent of 3 times b to the power of 2 times 3, which is 6. Next we have the base of 2t to the power of 15. So again, I want to make note that 2 has an exponent of 1, and so does t, and it's raised to the power of 15. So we have 2 to the first power raised to the 15th power. We have t to the first power raised to the 15th power. So 1 times 15 gives us a base of 2 with an exponent of 15. 1 times 15 gives a base of t to the power of 15. And then the next thing we need to do is evaluate 2 to the 15th power. Well, 2 to the 15th power, if we want to use our calculator, we would say 2, we're going to use our exponent and raise it to the 15th power, gives us 32,768 times t to the 15th power. Next, in part C, we have a base of negative 2 w to the third power raised to the third power. Now, negative 2 has an exponent of 1, and w has an exponent of 3. So we're going to have negative 2 to the first power raised to the third power times w to the third power raised to the third power. Well, negative 2 to the third power, if I put that in my calculator, I'm going to put in negative 2, and I'm going to raise that to the third power. That gives us negative 8. Times w, we're going to multiply those exponents, 3 times 3, which gives us an exponent of 9. So the result ends up being negative 8 times w to the 9th power. Next, we have 1 over the base of negative 7z to the 4th power. So if we take a look at the base, negative 7 has an exponent of 1, and z also has an exponent of 1. So it's going to equal 1 over negative 7 to the 4th power times 7 to the 4th power. And again, both negative 7 and z have an exponent of 1. Well, this becomes negative 7 to the 4th power. Let's go ahead and put that in our calculator. So negative 7 to the 4th power gives us 2,401. And then we have z to the power of 4. So it's going to be 1 over 2,401 z to the 4th power. Next we have e, the base of e to the negative 2, f to the positive 2 to the 7th power. So the first thing we want to do is distribute this exponent of 7. So we're going to have e to the negative 2 to the power of 7 times f squared to the power of 7, which is going to equal e to the negative 2 times 7 times the base of f to the power of 2 times 7. So negative 2 times 7 is going to give us a base of e to the negative 14, and f to the power of 2 times 7 gives us a base of f to the positive power of 14. Now, since the base e has a negative exponent, we can't leave that as a negative exponent. So in order to rewrite this with a positive exponent, The reciprocal means that this is now located in a denominator to make it a positive exponent. So we have f to the 14th divided by e to the 14th.